dividing polynomials. So we're going to look into dividing polynomials, which will lead us to eventually, because we're going to look at rational functions, which are special types of functions where we have division of polynomials. Alright, and dividing polynomials allowed us to simplify, factor the function. It allows us to find our zeros a little easier, right, and identify our zeros. So 4.3 is on dividing polynomials, the division algorithm, synthetic division, the remainder theorem, and so again, this is what we're going to get into in this section. Alright, so the first one is the simple case, dividing monomial. Monomial means a one-term polynomial, and so when we take a polynomial and divide it by a one-term polynomial, it's a lot like the distributive rule for multiplication. It basically is the distributive rule because dividing is the same as multiplying by the reciprocal. And so what you do is you divide each term in the polynomial by the single term divisor. Right? This is the divisor, this is the function I'm dividing it into. And so what you do is you split the fraction. So I divide each piece instead of the total. It's kind of like when I distribute it, I'm multiplying by the total, and I do it one part at a time when I distribute. So I'm going to take my 10x cubed divided by my 5x minus my 5x divided by my 5x, and then I simplify. Alright, simplify means reducing, and so 5 divides into 10 and gives me out a, not a 5, a 2. 5 divides into 10 gives me 2. I have 3 x's here. I divide it by 1, and so that's going to leave me with x squared. 5 divided by 5 is 1. X divided by x is 1, and so I'm just left with 1 in that last term. And so that's what that function simplifies to when I divide it out. So 10x squared minus 5x over 5x simplifies to the expression 2x squared minus 1. Alright, so I'm going to do a second example. So same thing, it's just more terms, but it's the same process. It's like distributing. I'm distributing the division. So I rewrite it and I divide every single term by my 4x squared. So my 2x to the 6th divided by my negative 4x squared, my 3x to the 4th divided by my negative 4x squared, and so on. And then you simplify. And the hardest part is then just make sure you're careful when you simplify. So the numbers divide, and sometimes I'm going to be left with a fraction. This first term I'm left with a fraction. 2 divided by a negative 4, well, you always write the reduced fraction. I can divide out the 2, so I'm left with negative 1/2. Alright, then x to the 6th divided by x squared. Well, remember, I subtract my exponent, so 6 minus 2 is going to leave me with x to the 4th. Alright, the second one, the negatives cancel, so I'm going to be left with a positive. 3 divided by 4 doesn't simplify, so I'm just left with 3/4. And then x to the 4th divided by x squared, well, I subtract, so 4 minus 2 is going to be leaving me with x squared. Alright, the next one, my 4 divided by my negative 4 is going to leave me with a negative 1. So I'm just going to write it negative. The 1 is going to be on my x term when I simplify it. So there's my negative 1. And so x cubed divided by x squared, 3 minus 2 is going to leave me with 1. And again, we don't usually write the 1 exponent. Oops. We just usually leave it x. So there's my negative 1x to the first. Right, the last term, negative 20 divided by negative 4 is going to leave me with a positive 5, right? Positive because the negatives cancel each other out. 20 divided by 4 is 5. And then x squared divided by x squared, well, that equals 1. And so it would be 5 times 1, which is just 5. And so this is what this function simplifies to when I do the division. And I've got one single polynomial there instead of 2. All right? And so that's the simple case. And so the next, we're going to get into the more complicated, the harder cases, the division of more complex polynomials. And we'll start with the long division case. All right, that's the next video.